Think about this for a second. Inside your head right now is the single most complex object we know of in the entire universe. It's a 3-pound organ that's running your whole world, every thought, every feeling, every single thing you do. It's what built civilizations, what wrote symphonies, and, kind of weirdly, it's what's trying to understand itself right now. But if you were to just look at it, it's really not all that impressive.
Yep, you heard that right. The very seat of your consciousness, the thing generating your entire reality, has the texture of cold butter. And for most of human history, this squishy, unimpressive blob was a total mystery. In fact, our first guesses about it were, well, they were almost hilariously wrong. I mean, just look at the difference here. On the one hand, you've got these crude, almost cartoonish drawings. That was the best guess from philosophers and early doctors for centuries. And on the other hand, you have what we see today, this vibrant, electric, living map of a mind actually at work. So how in the world did we make that leap? How do we get from A to B? Well, that's the incredible journey we're going on. It's a story filled with some truly bizarre theories, one horrific accident that changed everything, and a technological revolution that finally gave us a window into our own minds. Okay, so to really appreciate how far we've come, we've got to start way back at the beginning, where our ancestors did, with a pretty profound misunderstanding of what the brain was even for. Get this, for thousands of years, we had it completely backward. The ancient Egyptians, who so carefully preserved organs like the heart, would just scoop out the brain and throw it away. Even a genius like Aristotle thought it was nothing more than a radiator to cool down our hot-blooded hearts. This wasn't some fringe idea. This was mainstream science for a very, very long time. And this deep misunderstanding would only start to crack because of one single terrible accident. And this is where the story takes a dramatic turn. In 1848, one moment, one man completely shifted how we saw the brain. The unbelievable story of Phineas Gage. This is where the modern quest to map our minds really kicks off. So Gage was a railroad foreman, a pretty respected guy. One day, there's a blasting accident, and a 3-foot-long iron rod shoots straight through his head. It goes in under his cheekbone and comes out the top of his skull, landing dozens of feet away. And here's the crazy part. He survived. He was walking and talking within minutes. But something was fundamentally wrong. See, before the accident, Gage was the model employee. Polite, responsible, everyone liked him. But after, his friends said he was no longer Gage. The man who came back was impulsive, foul-mouthed, and just couldn't stick to a plan. The physical damage to his brain had completely rewired his personality. For the very first time, here was undeniable proof. A specific part of the brain was linked to who we are as a person. And this was the light bulb moment. Gage's case gave birth to this huge idea called localization of function. It's the concept that different parts of your brain do different things. Suddenly, things like personality and decision-making weren't some mystical property of the soul. They were jobs being done by a specific part of the organ in your head. And that idea kicked off a race to map out the rest of this uncharted territory. So, with this new idea that location is everything, scientists started the long, slow process of figuring out which part did what. And, the first attempts were a mix of, honestly, some wacky pseudoscience and some absolutely brilliant detective work. At first, you had things like phrenology, the belief that you could literally read someone's personality by feeling the bumps on their skull. Yeah, that was a thing. Totally wrong, of course, but it did get people thinking about localization. But then real science started to take over. Doctors like Paul Broca and Carl Wernicke studied patients who had trouble speaking, and after they died, they found damage in very specific, very consistent spots in the brain. The map was slowly, piece by piece, being drawn. But just stop and think about how incredibly slow and frankly grim this whole process was. The only way to learn was through tragedy. You'd have to find a patient with a very specific problem, say they couldn't understand language, and then you'd have to wait, sometimes for decades, until they passed away to finally look at their brain. To really understand the brain, we had to find a way to look inside while it was still alive and working. And that brings us to the 20th century and the technological explosion that changed neuroscience forever. Because for the first time, we didn't have to wait for an autopsy. We could finally, at long last, open a window into the living, thinking brain. The first big step wasn't about seeing, it was about listening. In 1924, the EEG allowed us to put electrodes on the scalp and pick up the faint electrical rhythms of neurons firing, the brain's waves. We couldn't see the structure, but we could hear the hum of the engine for the very first time. Then, in the 1970s, we finally got our first pictures. CT scans used a series of X-rays to create these incredible cross-sectional slices of the brain. For the first time, we could see its detailed internal structures without cutting anything open. The mysterious black box was finally being lit up. PET scans took it a level deeper. It's not just a static picture anymore. By tracking how the brain uses its fuel, glucose, we could now see which parts were working the hardest during a task. We could actually see which areas lit up with activity. And that brings us to the real game changer, the fMRI. It works on a simple principle. Active brain cells need more oxygen. By tracking the flow of oxygen-rich blood, we can see exactly which brain regions are firing second by second. This is it. This is the dynamic movie of the brain at work. We can literally watch as different networks come online to create a thought or feel an emotion. So, after this long journey from total mystery to a detailed map, what does the brain look like to us now? What has opening this window actually revealed?
Well, it revealed a universe. Using modern tools, we can take a journey, slice by digital slice, through the entire organ and just appreciate its breathtakingly intricate structure. It's a level of detail those early pioneers couldn't have even imagined in their wildest dreams. And the scale is just staggering. Your brain has about 100 billion neurons. To put that in perspective, that's more stars than there are in our entire Milky Way galaxy. But it's not just the number of cells that's mind-blowing, it's how they're all connected.
This image right here, this isn't just some pretty abstract art. You are looking at the brain's wiring, its information highways. And what we're learning now is that it's not just one spot doing one job. Complex things like creativity or empathy don't live in a single address. They emerge from this incredible symphony of connections, a conversation happening across the entire brain. I think this quote just sums up the whole journey perfectly. For thousands of years, it was a lump of tissue we completely misunderstood. And then, through a slow, difficult, and sometimes tragic process, we've carefully peeled back its layers, only to find the most complex and beautiful machine in existence. And that leaves us with this final, kind of mind-bending question. We've gone from literally throwing the brain away to mapping its deepest, most intricate connections. But can this 3-pound organ, with all its power, ever really, truly, and fully comprehend the very thing that is doing the comprehending? Now that might be the greatest mystery of all.